One of the key tools we can actually use in season is plant tissue analysis. Because not a lot of nutrient uptake has occurred before squaring and there's not a lot of pressure on the plant, we usually wait till about the start of the reproductive stage, unless there's unusual symptoms there that may be related to something like a trace element deficiency. The critical period is to get an understanding of what's happening between squaring and flowering and the first bulb being set, because once those bulbs are set, the nutrient demand goes exponential and it's just hard to get some nutrients into the plant. You've got two options with plant tissue testing. One is to take the leaf and one is to take the petiole. The leaf is best for your major nutrients in total and certainly for trace elements. We can use the petioles by themselves for N and K. The technique that we tend to use is make sure that the crop is not stressed in any way. Obviously at that time of year it's usually water stress, so we pick a time between when it's out of any waterlogging stress and before it starts to stress at the other end. The other stresses that can be important is cloud cover. We want the plant to be metabolising as quickly as possible, so if we've got overhead cloud or we've had a period of cloud, then sometimes it's better to wait a day or two. Early on, cold stress days you would avoid, and again leave it a couple of days afterwards for the plant to be actually cracking on and growing as it should be. Anything that affects normal plant growth that you could expect at that time of year is going to either cause a dilution or an accumulation of nutrient. We want to know what it's like growing normally with the supply that it's got, and is that supply going to be adequate. If it's just a general look at the health of the crop, I generally direct people to where the moisture monitoring equipment is located, because then we can start to relate the data coming out of the plant samples back to what's happening with moisture at a local place. Where there are unusual patches in the crop and you think they're nutrient related, take some good and bad, because then we can use those to actually calibrate what's going on. Being consistent in the leaf that you actually take from the plant is important. We want things of similar maturity, both in the plants that we sample across the field and if we come back to sample later. Leaves with similar maturity have similar nutrient content, so if there's a change in the soil supply, it'll reflect itself in the leaf. The way to select the right one, looking at the youngest mature leaf, we don't want that one. It's not maximum size, it hasn't reached its full potential and its nutrient requirement. We're looking for the one that is maximum size. It's generally the third or the fourth, depending on the time in the year that you take them. So we've got one here that's very small, we've got a small one here, and the next one is this one here. The technique is just to remove the leaf and petiole. If you want to send them both away separately for different readings, you can, but the leaf sample must have the petiole removed. And one mistake that people make is that they don't do that in the field. They pick all the leaves and take it to the lab and do it. It continues conductance of material out of the petiole into the leaf and you end up with a false reading. Laboratories require to run a full scan of nutrients, about 20 grams of dry material. So if we know that the leaf's about 90% water, and you're looking at a minimum of about 200 grams of fresh material. The reason why I don't say how many leaves is because obviously early in the season they're small. Later in the season it takes fewer. It's just trying to get a representative sample of the leaves from the area and sufficient quantity to satisfy the laboratory's requirement. For petioles, it's generally around the 30 to 40 petioles. Like anything, if it's very variable, the more the better. Maintain it at least the temperature or below the temperature that it actually left the field. So taking it and throwing on the dashboard of the car and the temperature gets to 50 to 60 degrees, higher temperatures tend to cause the things to bleed. So we end up some of the nutrient content coming out and we don't want it on the bag that it's in, we want it in the plant. If it's not too hot, then the lab's going to dry it anyway, so drying out's not a problem. It's just about getting it there quickly, because generally when we take plant tissue results, we want the results for an action in crop, which needs to be as quick as possible.